Okay, we're going to do some trig identities. I'm going to try and get through 4 examples. I'm not sure if I will be able to, but you need to do this on lined paper. Okay, so there's no handout for this. So the first one, get a piece of lined paper and let's go. We're just simplifying. We're not doing trig identities yet. Sorry. Secant over sine minus secant over cosecant. Okay, so step 1 is to try and change everything into sines and cosines. You ready? Here we go. The definition of secant is 1 divided by cosine. So we have 1 over cosine over sine minus, and we have secant again, which is 1 divided by cosine, and over cosecant. Cosecant is 1 divided by sine. Okay, so now we're going to figure out, like, what does this mean? Sorry. We have 1 over cosine, which we're going to change to this, 1 over cosine. Now, how do you divide by a fraction? We divide fractions by making this is sine over 1, right? So we're going to change, we have 1 over cosine, which is here, and we're going to multiply by the reciprocal of this. That's how you divide fractions, multiply by the reciprocal. So we have 1 over cosine came from here, times the reciprocal of this, okay? Minus 1 over cosine times the reciprocal of 1 over sine, which is sine over 1. Are we getting closer? Not really. So, what we need to do in order to add and subtract fractions is we have to have a common denominator. So this will have a common denominator if we multiply, this has cosine times sine, and this has cosine times 1. So if we multiply this, what does this one need to look like this one? This one needs a sine, right? So we're going to multiply this by sine over sine. And now do you see how they are a common denominator? Cosine times sine, cosine times sine. These are all equal. So our denominator now is cosine times sine. And in the numerator, we have 1 times 1 minus 1 times sine times sine. Sine times sine is sine squared. Okay, this you should notice 1 minus sine squared is one of our trig identities. So we know that cosine squared plus sine squared equals the number 1. So 1 minus sine squared, if I were to subtract the sine squared from both sides, what's 1 minus sine squared equal to? Cosine squared. So I'm going to replace 1 minus sine squared with cosine squared. Okay, what do you notice? What's a common factor in the numerator and the denominator? Do you see how there's a cosine in both? So just like if we were to have, watch, if we were to have x squared over x times y, what would that reduce to? Would an x divide out and we would get x over y? So here, one of the cosines cancels. And we get cosine, that one canceled, over sine. What is cosine over sine equal to? We have a another trig function that's equal to cosine over sine. Sine over cosine is tangent, so cosine over sine is equal to cotangent. Okay, isn't this fun? We have substitutions, we have getting fractions together by making a common denominator. We had a substitution here using the Pythagorean identity. We canceled, and then we changed this into another trig function. That's example 1. Extra example. You ready for extra example 2? I don't know if I'm going to have room for this, but we're going to start. Okay, extra example 2. Cosecant, parentheses, secant, minus cosine. Now I'm wondering, should I distribute first or should I change first? I think I'm going to distribute first, okay? So let's distribute this cosecant. So we have cosecant times secant minus cosecant times cosine. Distribute first. Now let's change these into sines and cosines. Okay, what's cosecant? Cosecant is 1 over sine, and secant is 1 over cosine. Okay, minus cosecant. What's cosecant? 1 over sine times cosine. It stays cosine. So change everything into terms of sine and cosine. Should we write some steps down? Distribute. Change to sines and cosines. Okay. Now we need to combine the fraction. So in order to combine the fraction, we have to have a common denominator. Nominator. I made it fit. Awesome. This denominator has sine times cosine, but this denominator only has sine. So what does it need to look like this one? It needs a cosine. So how do we do a cosine? Multiply top and bottom by cosine. I'm going to make it squeeze. Sorry if that didn't fit on yours. Here we go. Now we have 1 minus cosine times cosine. Cosine times cosine is cosine squared, and our common denominator is sine times cosine. What is 1 minus cosine squared equal to? 1 minus cosine squared is equal to sine squared. So we're going to substitute that out. And I'm going fast because you can pause. Once I substitute that out, now you see we have a sine squared over sine. So what cancels? A sine cancels. And we're left with 1 sine on top in the numerator over cosine. And what is sine over cosine equal to? Sine over cosine is the definition of tangent. Extra example number 2, done. Extra example number 3. Here we go. You ready? We're going to do this one. Cosine over 1 plus sine plus tangent. What should we do? Let's change tangent into sine over cosine and see if we like that or not. Definition of tangent is sine over cosine. I don't want to get a common denominator right now because I know that this is 1 plus sine. And if I multiply this by 1 minus sine, I'm going to get something awesome. So let's try this. Okay. So this numerator here, I'm going to leave it factored. 1 minus sine theta times cosine theta. Now, I'm going to multiply it by the conjugate here. And when the conjugate, if you were to FOIL that out, it would be 1 minus sine squared. Now, we're not touching that. Because 1 times 1 is sine, 1 times 1 is 1, 1 times sine is sine, 1 times negative sine is negative sine. So those two middle terms cancel, and then we get 1 minus sine squared. Okay, you tell me now, we've done this already, what's 1 minus sine squared equal to? 1 minus sine squared can be substituted out for cosine squared. One minus sine squared equals cosine squared. You guys see that? Okay, what cancels now? Do you see the cosines cancel? And we get 1 minus sine squared, no more cosine, on top, over cosine. What do you guys see? Do you see how we have a common denominator now? Woohoo! Okay, common denominator. What does common denominator mean? We can add the numerators. 1 minus sine theta plus sine theta all over cosine. What happens to our sines? They cancel. And we get 1 over cosine. What's the definition of 1 over cosine? 1 over cosine is equal to secant. Isn't that so neat? That whole thing from the beginning goes to secant. Is there an easier way to do that or a shorter way? Maybe. There's lots of ways. Lots of ways. How did I know to do this? I saw 1 plus sine, and I know I can multiply it by the conjugate to get 1 minus sine squared, and 1 minus sine squared is cosine squared. So to me, the cosine squared then cancels with the cosine on the top, leaving just 1 cosine, which matches this denominator. All right, we're going to try and fit in one more. These are fast. These are just 4 extra examples. And maybe we're going to use our little trick from before. Do you see how this says secant minus 1? What should we multiply by to create that difference of 2 squares? Let's multiply by secant plus 1. Secant plus 1. And this is cosine minus 1, so we're going to multiply by cosine plus 1, top and bottom. And let's see what happens. I don't know if this is right, but we're going to try it. Okay, that's what trig identities is all about. You try something. Do you agree that 1 plus secant and secant plus 1 are the same exact thing? So this is 1 plus secant all squared like that. Now what's this going to be? This is going to be secant squared minus 1. And that's going to substitute out. Plus 1 plus cosine all squared all over cosine squared minus 1. Okay, both of these are trig identities from the front page. Okay, so I substituted this out for tangent squared and substituted this out for negative sine squared. I'm having an issue with time. So I don't think I'm going to finish this, so I'm going to have to finish this later. Finish later. Dun 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 dun, the suspense. Okay, thanks for watching.